Welcome to VCAT again. This is David Lee, and I'm with Virginia Asphalt Association. And let's go over that homework that you did. So we have that homework review. I hope all of you have taken the opportunity to actually walk through this homework, because this is one of the critical elements of when you take the exam in particular, but it also helps you learn how to walk through many of the specifications that VDOT has. This is part of the Field Level 2 class again, so let's go over this homework. First thing I want to do is remind everybody, and this is where one of the hiccups will occur when you're doing these types of problems, or if you're trying to answer questions out in the field. It happens frequently because this hierarchy of specifications that VDOT has is very important. You've heard us talk about this numerous times throughout this class and any other class that you might take, because it's very important. There are many specifications within VDOT's realm, whether it be in a specification book, or it be a supplemental specification, or it be a special provision, but there's a hierarchy to all those. So you have to be sure you understand that hierarchy. We've talked about it, standard drawings at the very bottom of that list, and you walk up that list to the standard specifications. That's that book that you see. Many people call it the VDOT Bible. It's a book that's got all the specifications in it. It happens about every 4 to 6 or 8 years. Then there's supplemental specifications that actually supplement that book directly. They apply to all projects. And then there's plans. So if you have a project that has plans, on those plans, those could have general notes in them. They could have all types of requirements that are actually in the plan set, and that plan set would overrule the supplemental specifications, the standard specifications, and the standards. Following on up the line, you have special provisions. Those you see a lot, those are actually in your contract. For each and every specific contract that's out there, there will be a series of special provisions that apply directly to that contract itself. And then there's, even further down that same line, there's special provision copy notes. Those notes are something that's added very specific to that contract, and it is something that you'll see occasionally in each contract. So keep that hierarchy in mind as you go through these types of problems. Whether it be for the exam, when you take this exam, it'll be very important, but it's also very important when you're working out in the field, because ensuring that you get the right answer is by following this proper hierarchy of all those specifications. So let's go over some of those key inspection points as you're going through this process. So during your density acceptance testing, which is something the Field 2 technician is responsible for, there's all types of things that you have to be aware of, and that you have to have a certain level of importance to each one of those. So site preparation, milling, tacking, we've talked about many of these. Equipment that's involved in each one, placement of the material that you're doing, in this case asphalt, and the compaction of that asphalt to try to ensure you get that actual proper density. All those are elements that are inspection points required for each and every process that's done on a construction project, or a maintenance schedule, or a paving operation. And then you have density acceptance, where you have the general requirements that are associated with general density acceptance, and small quantity applications. Don't forget there's that VTM, the Virginia Test Method 76, which outlines much of that testing steps that you have to take through that. And you'll break it down into QC test lots and sections. That's whether you're using a method A for density or a method B for density. You have to keep all that in mind. And then on VDOT's side, they have to do that independent assurance. They have to verify that all the equipment's correct. They have to ensure that the testing processes are correct, and that's part of that independent assurance. They also have to do verification testing and sampling, where they actually test the material to see if it passes the specifications, just like the contractor does, say, in a lab, or when they're actually running the density test out on the roadway. They do that as a verification step. And then lastly, there's a referee procedure. So if it turns out that for some reason things don't agree, that the verification testing says that maybe material fails and the contractor's test says it's passed, there's a referee process in place so that you can walk through that and ensure that the proper decision's made for that specific section of roadway. Find the spec. This is, again, what we were talking about. You're going to be going through this process during the exam. You have to actually search for specifications and specification requirements. And you need to know where to look and which ones to look at. Again, referencing back to that hierarchy. So our first question was, a secondary route will need patching prior to an overlay. And it's a standard route. And so the first thing you're looking for is how many types of patching are identified in the VDOT special provision for 323 for asphalt shoulders, patching existing flexible and rigid pavement and shoulders. So that's the first question. The second was, if that patch depth is 4 inches, what material shall be used? And then the last question, what is the unit price for a type 3 patch when the SM12.5A is used at $60 per ton? So let's walk through the answers to each one of those. So how many types of patching are available or identified in the special provision? There's 3 of them. There's a type 1, type 2, and a type 3. So there's 3 different types of patching identified in that special provision. So if you have a patch that's 4 inches, what material shall be used? Well, if you go to the supplemental specification for 323, you'll see a chart that breaks down different depths of patching. In this instance, you got 4 inches, and you'll see that a BM25, it'll actually show it in the nominal maximum aggregate size of 25.0, which is a base mix. So the base mix is what's required for this type of patch. And then what's the unit price for a type 3 patch if you're using a surface mix and it's $60 per ton? Within that supplemental specification for a type 3 patch, it says it's 5 times the unit price. So all you do is take 5 times 60 and you get $300. So find the spec for number 2, question number 2. We had a project with scabbing. The engineers decides to scratch the milled surface. It's determined that 65% of the pavement will need to be scratched. So in this case, we're over 50%. That's important if you look at the specifications. So you're at 65% of the surface needs to be scratched. So now, what type of surface preparation is required? And again, what's the cost basis for that type of surface preparation? So now if you go to supplemental specification 323 for asphalt surface preparation and overlay, you'll see that a type 2 is required in this instance. So you're over 50% of the roadway. If you're over 50% of the roadway, you need a type 2. What's the cost basis for surface preparation in this instance? So in this case, for this type 2, it's 1.5 times the unit cost per ton for that mix that you're using. So if it was $60, now you multiply that by 1.5 and you'll get $90, right? So let's look at number 3. In this case, we have an existing pavement that needs to be crack sealed prior to an overlay. So you're going to go out there and do proper crack sealing on the roadway, and you need to determine a few things, right? So what's the maximum crack width for sealing according to the VDOT specifications? And for a type C construction method, what is the maximum height that sealant can be above the pavement surface? So what do? Well, again, you go to that supplemental spec for 322, asphalt surface preparation and overlay, and it talks about the requirements for crack sealing. Well, you'll see that it says that the maximum crack width for sealing is 1.5 inches. So you should not seal a crack that's any larger than that, because the crack sealing will not be effective. For a type C construction method, what is the maximum height? Well, it's 1/8 inch. So in this case, for type C, your maximum height of the sealant above the pavement surface is 1/8 of an inch. So question number 4. Prior to paving the roadway, the contractor tacks the existing surface. So if you remember, we had a presentation on tacking. So now, within how many tons of the mix being placed shall the tack rate be checked by the engineer, or in this case, most likely the inspector? So within how many tons, once you start, when do you need to take that first test? The engineer believes, though, after it's done, that the contractor didn't clean that milled surface well enough before tacking and paving. How many cores must be taken to determine if the shear strength of that tack coat bond meets the requirements? How many cores do you have to take? And then, if the average bond does not meet the minimum shear strength of 100 psi, what's the pay adjustment for that? So now, what do? Well, Road and Bridge Section 310 for tack coat details out all the requirements associated with this. And it'll tell you that within the first 500 tons of mix that's being placed, you need to be running one of those tack application rate checks. So you'll go out there and you'll put your plate down and you'll check it, but it has to be done within the first 500 tons. So if the engineer believes that it wasn't cleaned well enough and he wants to check the bond strength, how many cores have to be taken? Well, you have to take 5 cores for shear strength testing at an absolute minimum to evaluate whether or not you have the proper bond strength for that section. And that's in that section 310 Tack code. And then lastly, what do you do if it doesn't meet that 100 PSI requirement? Well, the specs detail out very clearly. It's a remove and replace. So if it doesn't meet the 100 PSI requirement, then the contractor will have to go out and remove and replace the section that those cores represent. So question number 5. We had the contractor that's elected to performance mill Interstate 66. So how far can the contractor performance mill? That's the first question. The second one is, how soon after milling does the contractor have to have that section paved back? They go out there and they mill it in accordance with that first question to a certain distance. How soon do they have to have it paved back? Next question is, determine if the surface was performance mill, what test is performed and how many locations are tested. So in this case, you actually have a couple of places you got to look. So if you remember the hierarchy, you're starting to look in there, you'll see that there's a road bridge specification section 515 for planing or milling pavements, but there's also a special provision for cold planing asphalt concrete operations. Both of those specifications will be utilized in answering these questions. So the first one, how far can the contractor performance mill? They can performance mill 4 miles in this case, according to those special provisions and standard specs. How soon after the milling does the contractor have to have that section placed back? And this is critical. Obviously, they don't want you to leave it out there too long. In this case, it has to be paved back in 96 hours. And then lastly, if they do performance milling, what tests are performed and in how many locations are tested? Well, if you go to that standard specification section 515, you'll see that the tests have to be performed in accordance with ASTM E965, and they have to do 10 random locations. So that's all in those 2 specifications, and you'll see that you have to actually go to both of those to get the proper answers to this question. Okay, so your question number 6, the contractor's overlay in US 360. The overlay thickness for the SM 9.5 is 1.5 inches. To complete the project, the contractor must pave each lane over a 4-day period. So, first question, what is the length of the temporary tie-in at the end of each production shift? And the second question is, what is the maximum amount of time that the contractor has to square up those travel lanes? So, in this case, again, we had the contractor overlay in US 360. We've clarified here, Route 360 is a 55-mile-an-hour speed limit. And that's critical if you go look at Supplemental Specification 322, Asphalt Surface Preparation and Overlay, which is where you'll find the answers to these questions. When you go there, you'll see there's a specific section that talks about roadways that are 55 miles an hour and over. In that case, when you read down through that, it'll tell you that you have to have 4.5 feet minimum for that temporary tie-in. So if you go look at that supplemental specification, you'll see that you have to have 4 to 4.5 feet for that minimum tie-in. That all ties back to that ACOT 1 that was talked about, and it tells you that you have to have 3 feet per inch of overlay. So you take 1.5 times that 3 feet, and you get 4.5 feet minimum for that tie-in. What's the maximum amount of time the contractor has to square up that roadway? Well, in this case, again, it's 55 miles an hour and over. There's a specific section that tells you it has to be done before the weekend. So he has to get out there and actually, if he's milled 4 miles, he's got to get that 4 miles squared up before the weekend. So question number 7, contractors paving State Route 43 in mid-October. Contractors paving an SM 9.5A. The mix was not produced with warm mix additive or process, so not the additive or the process for warm mix, and the mix has 26% wrap. So what is the minimum base temperature for that mix? What's the minimum placement temperature for that mix? And if the existing base happens to be 47 degrees Fahrenheit, can the contractor start paving? So let's answer those. And those are found in your road and bridge section 315 for asphalt concrete pavement. And you will see that the minimum base temperature for that mix is 50 degrees. Some people say, well, wait a minute. I look in there and I can see that it says 40 degrees. Well, keep in mind, you got to look at the spec closely, because in this case, it's critical to note that you're not using a warm mix technology. So if you use a warm mix technology, you can go down to 40 degrees. But if you're not using a warm mix technology, it's 50 degrees in this case. What's the minimum placement temperature for this mix? It's 270 degrees. Again, it's not a warm mix technology. If it was a warm mix technology, it would be less than that. So in this case, it's 270 degrees. So if the existing base is 47 degrees, can the contractor start paving? Well, you kind of answered that in the first one, because it says it has to be 50 degrees, again, because you're not using a warm mix technology. So no, they cannot start without approval of the engineer. So if it turns out maybe the temperatures are rising rapidly, you may go to the engineer and they say, hey, can we go ahead and start? It looks like within the next 30, 45 minutes to an hour, we'll be well over 50 degrees. They may allow it, but you have to go ask for that. The answer is no, you cannot start because you're less than 50 degrees without specific approval from the engineer. So find spec, number 8. The Fredericksburg District specified SMA 12.5 on US Route 1. The total project length is 13,000 feet per lane with 2 lanes per direction. So you need to read this question very carefully. First part of that question is, how many standard size lots will the contractor have? And then the second is, how many cores will the contractor have to take for density acceptance purposes? So let's find the answers to that one. Remember, this was a SMA mix, so now you have to go to section 317. It's not a standard mix, it's a stone matrix asphalt concrete, and that's found in section 317 of the road and bridge specifications. First question is, how many standard lots will the contractor have to have? So the answer is 12 lots. How did we get that? Well, we had 5,000 feet as a standard lot. If you remember, when you do density testing, standard lot is between 3,000 and 7,000, with the standard lot being around 5,000 feet. So if you got 13,000 feet per lane, you get 2 lots for every 5,000 feet, and then you'll have at the end of it a 3,000 foot lot. Minimum was 3,000 feet, so you get an extra lot there. So that's how you calculate that to get to 12 lots. Don't forget, it says that you have per lane, and you've got 2 lanes per direction. So how many lanes do you have? You've got 4 lanes. So that's how the calculation is done to get that 12 lots. You've got 4 lanes, 2 lanes per direction. You've got a standard lot 5,000 feet, so you get 3 lots, because you have a 5,000, another 5,000, and a 3,000 for each one of those, and then you have to multiply that by 4 because you've got 4 lanes total. That gives you 12 lots. How many cores will the contractor have to take for density acceptance? Well, you got to take 1 core for every 1,000 feet. So this is a pretty straightforward calculation. You're going to need 52 cores, right? Because you had to take 1 core per 1,000 feet. That's all found in section 317 of that stone matrix asphalt road and bridge specification. So number 9, Nova District decided to lay SM 4.75D on US Route 50 at an application rate of 110 pounds per square yard. So this is a fine mix that's been laid in Northern Virginia District. What type of and size of roller must be used at the breakdown position in compaction? So your initial breakdown roller, what size does it have to be? What is the minimum core density for SM 4.75D? Here's the answer for this question. We got Northern Virginia District laying down that 475 on Route 50 at 110 pounds per square yard. First question was, what type and size roller must be used in the breakdown position? Well, the answer to that is it has to be a steel wheel roller, and it has to have a minimum weight of 10 tons. Second question was, what's the minimum core density for an SM 4.75D? You'll see when you look in section 315, supplemental sections 315, that there is no minimum core density for SM 475. because it's defined as a thin lift asphalt overlay. It's less than 125 pounds per square yard. So if you're less than 125 pounds per square yard, in this case we were 110 pounds, then you do not do any core density testing. So in this case, no cores are taken. You have to do that minimum size roller. Number 10, nuclear gauges are used for density acceptance and monitor testing on a project. So the first question is, what is the maximum time between calibrations for that nuclear gauge? The second one is, who is required to perform all that density testing for that? What requirements are there for the person performing density testing? And then if the lot density is found to be at 96.5% of that control strip density target, what's the pay adjustment? So if you've gone out there and they've placed it all, you've done all your testing, and it comes up that you're 96.5% of your original control strip, what's your pay for that section? So if we go to supplemental section 315 of the asphalt concrete placement specifications, we will see that the maximum time between calibrations is a maximum of 12 months. So every year, that nuclear gauge has to be calibrated. Who's required to perform the testing? What are the requirements for the person that's doing all that density testing? Well, they have to be asphalt field level 2 technician certified. That's why many of you are taking this class, is because you will be the ones actually performing this testing, or at least be responsible for that testing. And so you have to be certified as an asphalt field level 2 technician. Last one is, if the density is found to be at 96.5% of that control strip density target, what's the pay adjustment? Well, at 96.5%, the pay adjustment in accordance with Table 3-4B of that supplemental specification 315 says you're only going to get 90% pay. If you recall, to get 100% pay, you need to be between 98 and 102% of that control strip density. We're well below that. In accordance with that table, you're paid at 90% of the rate for this specific mix. Number 11. In this case, we've got a quality assurance program that's comprised, if you recall, of all those components, whether it be quality control, acceptance, verification, sampling and testing, VST, and independent assurance. So the first question here is, how many independent assurance cores are needed if the contractor has constructed 26 control strips? So they've been out there paving, and they've had to do 26 separate control strips during this paving operation. It may have been over months. How many cores have to be taken out of those control strips? Second one is, during the first week of paving, the contractor has completed 9 test sections and lots. What's the minimum number of test sections that must be tested for that verification, sampling, and testing? And then how many cores must be taken and tested out of those test sections and lots? So let's see what we find in the specifications. You search through our specifications, you'll see that in accordance with the manual of instructions in this case, and you have a copy of that in your specifications book, section 503 of the VDOT manual of instructions says that you have to have a minimum of 10% of those control strips. You got to take cores from a minimum of 10%. What did we say? We had 26 of those, right? So if you take 10% of that, you get 2.6. We always round up in this case, so you need 3 control strips tested with a minimum of 1 core per control strip, so you have to have 3 cores. So we had 26 control strips. We needed to test 10% of that, so we wind up with 3 separate cores for independent assurance. During the paving, the contractor completed those 9 test sections and lots. So what's the minimum number of tests that have to be taken for VST? Well, if you go look at the requirements that are in the manual of instructions in section 503, you'll see that a minimum of 20% of those test sections or lots have to be tested. And in this case, we had 1.8 test sections, or therefore we have to have 2 test sections that are tested for VST. The second part of that question was, how many cores must be taken and tested out of those test sections and lots? Well, we have 2 sublots per VST lot. So that means you got 4, right? So we had 2 before. We have to have 2 sublots per VST lot. So we wind up with 4 cores in this instance. All this is found again in the manual of instructions, section 503. and you have a copy of that in your specifications book. Now, I want you to go back and I want you to do the exercise number 2 on your own. So you need to walk through all those questions that are a part of exercise number 2. When you get done, you'll find that the answers to each one of those in the back of the manual. I highly suggest you take the time to go through these and walk through these. This is one of those areas that people just need the practice of walking through all the specifications so that they can see all the nuances associated with that hierarchy we talked about. You'll see in many instances you might find an answer that's in both the standard specifications, but it may also be in the supplemental specifications. In that instance, what rules? Well, the supplemental specifications would overrule the standard specs. So you'll have to do that and go through these questions to get yourself comfortable with ensuring that you're looking for the right answer and that you find it in the right place. With that, I appreciate it. If you have any questions, please see your facilitator. Thank you.